Good afternoon, everyone. Welcome to the class of CE 333 Environmental Engineering 2. So, in our last class, we were discussing this problem, okay, and which is on the water supply, designing the water supply system for a tall building. And we explained the problem to you, okay. Now, first, to design a water supply system, we must decide on minimum permissible fixture pressure. Let's discuss this. This is your building, for example. Okay, this is your building. Now, and this is the overhead water tank. This is the overhead water tank. Clear? This is your fixture, for example. This is a basin, and you have a faucet here. Faucet means tap, water tap. Okay, the water will come and go here. Now, as I told you, every fixture needs a minimum pressure to function properly, right? Now, if you supply water from this overhead water tank to this fixture, then where would you get the pressure from? P. Where would you get the pressure from? P equals to what, guys? Gamma into H. Am I right? Now, your pressure, you will get this pressure from H, that means this height difference. Higher is the pressure, higher is the elevation, H, higher will be the pressure. Now you tell me, there is another fixture here. Here it is P1, here it is P2, here it is H1, and here it is H2, right? So P1 equals to, let's see like this. P1 equals to gamma 1, gamma H1, P2 equals to gamma H2, and since we are dealing with the water here, so gamma is the unit weight of water. So P1 is the pressure coming from the elevation H1, P2 is the pressure coming from the elevation H2. Now tell me which one is larger, P1 or P2?
Me too.
P2, because H2 is higher. So as you go downward for this down feed down feed system, why? Because water is flowing downward. So this is a down feed system. In this down feed zone, in this down feed zone, the who will get the minimum fixture pressure? The top one, right? The top fixture. Now, if this fixture has a minimum requirement of, for example, 8 psi, 8 psi, then you need to provide enough H here. Am I right? Enough H1 here. Am I right?
Yes, sir.
Okay. So there is a minimum H1 requirement also, because you have a minimum P1 requirement. And P1 equals to what? Minimum. At least greater than or equal. Let's write this, greater than or equal. That means minimum 8 psi. Now, in a downfield arrangement, the highest fixture, I mean the topmost fixture, those nearest elevated tank, this is the smallest fixture because they benefit least from the static gain. Static gain means gain, pressure gain from the elevation. Okay. Static pressure increases at a rate of 0.434 psi per feet. 0.434 psi per feet. That means if you increase 0.434 psi per feet, that means if you increase your elevation 1 feet, then how much pressure you will gain, or gain, guys, in this case? 0.434
Point
psi.
four three four.
Did I make it clear? Did I make it clear?
Yes, sir.
Yes, sir.
How? You can always try this. Look, P is equals to gamma I. So gamma equals to what, guys? 62.4, right? Pound per cubic feet for water. Am I right?
Yes, sir.
Into H is what, guys? For 1 feet, right? So put 1 here. So P will be 62.4 pound per cubic feet. Now, if you convert this to pound per square inch, this is pound per cubic feet. If you convert this to pound per square inch, then what you have to do? You have to do this 62.4 divided by 1 feet equals to 12 inch, right? Am I right?
Yes, sir.
Yes, sir.
So this is actually PSI, pound per square inch. And tell me if you get this value or not. Tell me the value from here, please. Uh,
Sir, is it 12 to
0.436,
the
sir.
power?
0.434, right? Wait a minute. 62.4 pound per cubic feet, and your this is your age, right? So pound per square inch. Oh, I'm sorry. I'm sorry. Uh,
Sir, yes, sir.
this has to be square, right?
Yes, sir.
This has to be square because why? Because this is. Um, let's do it again. P equals to gamma age. So 62.4 pound per cubic feet into H is what? 1 feet. We want to see how much pressure we get from 1 feet elevation. So from here we get 62.4 pound per feet square because this feet and this feet cancels out. So what's remaining? Square feet. Now if you convert it to inch, then you will get, now tell me the value please. Pound per square inch.
0.433.
0.43, let's say 0.44 psi. So for 1 feet elevation, you get 0.44 psi pressure. Now, if your minimum pressure requirement here is 8 psi at this point, how much, guys? You have to provide 8 psi. Anyhow, you have to provide how many? How much?
8.
How much? 8 psi. So for for 0.43 psi, 44 psi, you need how many feet? 1 feet. So for 1 psi, how many you need? 1 by 0.434 feet. So for 8 psi, how much do you need, guys? 8 divided by 0.434. Am I right?
Yes, sir.
Tell me the value, please.
18.43.
18.43. Now here is the feet. So this amount of elevation you need to gain 8 psi here. How much H1 has to be what? 18 psi. But here is a catch, guys. As the water flows from this pipe, there is a loss due to friction. Am I right?
Yes, sir.
Loss due to friction. So if you provide exactly 18.43 feet here, then some of it will be lost due to the friction. For example, your 2 psi has been or 1 psi has been lost. For example, 2 psi. Then how much is remaining, guys? 8 minus 2 equals to 6. So how much you will get here, guys? Instead of 8, you will get 6, right?
Yes, sir.
Okay, so that's the problem. That means you have to provide more than 8 psi because some of them will be lost. So instead of 18.43 feet, you increase this to 23, 4, let's say 25 feet. Did I make it clear?
Yes, sir.
So the minimum height of the overhead water tank from the topmost fixture of this building, that means this one, has to be this height. I'm talking about this height. Has to be at least approximately 25 feet. Is it clear to everyone?
Yes, sir.
Okay. Why didn't I take this height, by the way? Because the water level will not always be at this location. It will be consumed and the level will be drawn down. Am I right? So you have to take the lowest level. Clear? Instead of taking this level, you have to take this level. Clear?
Yes, sir.
Yes, sir.
Yes.
Now, can you remember that here they told that flush valve fixtures will be used in all of the floors except flush valve will be used in all of the floors except these two floors where flush tank will be used. Why? Because for flush tank, minimum fixture pressure requirement is 8 psi, but for flush valve, minimum fixture requirement is 15 psi. So if you had given flush valve here, then you would require 15 psi minimum fixture pressure, and therefore your required height elevation would have been 15 divided by 0.434. Am I right? What is the value, guys?
34.56.
34. That means you have to provide at least 40 feet, approximately 40 feet. So that will require much more cost to construct this overhead water tank at 40 feet. Now you require 25 feet, but in that case you would have required 40 feet, which is expensive. So we did not provide flush valve at the top floors. Did I make it clear?
Yes, sir.
Okay. So first of all, you need to determine the minimum height of the overhead water tank from the uh, top fixture. Okay. So that's all they have been telling this. Okay. Same thing. Okay. Now zoning. You have to determine that which floors will be uh, supplied water by what type of arrangement, downfeed arrangement or upfeed arrangement. First of all, look at here. How much here it is given, guys? 50 psi. What is the pressure available at the main from the Dhaka Wasa or any other public water service authority? 50 psi here. So let's see how much we can gain. How many floors you can gain by this 50 psi. Clear? So
Yes,
let's
sir.
look at this. Now, to go there, we need to remember when the water will be supplied from this pressure like this, the what is the direction of the water? Upfeed, up,
Upward.
upward. So this is upfeed zone. Okay. For a upfeed zone, for a upfeed zone, what is the source of energy? What is the source of energy? Always remember, source equals to whatever you call. I mean, the energy from input should be output. Let's call it like this. Input energy. Input energy equals to must be equals to the output energy. Now, in case of this upward flow, I mean upfit zone, what is the input energy, guys? Where
The
are
50
you getting
psi
the
divided by
energy?
1.
50 psi. 50 psi, you are getting this, right? This is the input, 50.
Yes, sir.
Now, some of it will be leveraged or used by lifting the water to upward. You have to work. You have to you have to exhaust energy. You have to spend energy to lift the water from here to upward. So that is basically here 0.434 into h. What does that mean? That means that if you lift it for h feet, how much energy you will lose? As I told you, 0.434 into h. For 1 feet, how much, guys? For
For
1 feet,
1.434.
0.434. For 1 feet, 0.434. For h feet, 0.434 into h. Clear?
Yes, sir.
For 1 feet, you lose
Yes, sir.
energy or you gain energy, 0.434. For h feet, you get this. And this is psi. Remember, this unit is psi and this is feet. So 0.434 into h. 0.434 into h. Okay, fine. Now, if you look at the topmost floor here, you have a energy, minimum pressure requirement. Am I right? Minimum pressure requirement. Am I right?
Yes, sir.
Fixture. Every fixture need to have a minimum pressure to function properly. And this is 15 psi because this is flash bulb. So 15 psi. So this is we'll call this small p. We'll call this small p. Small p plus 0.434 into h plus small f. Let's call this frictional loss. As I told you, as the water passes through the pipe, there is always loss due to friction and others, and this is frictional loss. And apart from the frictional loss, if you look at this, if a pipe is like this, then there is a bend. So as the water moves, it will be hindered. The movement of the water will be hindered by this bend, right? So there is also losses associated with this. Sorry, losses associated with this. Clear? So this is also a loss. Did I make it clear?
Yes, sir.
Yes, sir.
So plus other losses.
স্যার এখানে ছবিতে যে একটা মার্ক করছেন টপ ফ্লোর হিসেবে, এটা কি আমার আপফিট জোনের টপ ফ্লোর?
Say it again. I didn't get your question.
স্যার এখানে আপনি ছবিতে দেখাচ্ছেন যে টপ ফ্লোর মাঝের দিকে, ওটা কি আমার আপফিট জোনের টপ ফ্লোর?
What did I show here? That water
স্যার
is
0.434 এর পাশে যে দাগ দিয়ে আপনি টপ ফ্লোর দেখাচ্ছেন সেটা।
I just wanted to describe that for 1 feet, how much you lose or gain, how much psi? 0.434 psi. If you lift the water to 1 feet, how much you lose? 0.434 psi. So if you lift the water to h feet, how much you lose? 0.434 into h. Did you get the answer of your question?
জি
Did
স্যার।
you get the answer of your question?
জি স্যার।
Okay. So input has to be output. So in case of an upfit system, your input is this and output is equals to minimum fixture pressure. Remember, this is minimum fixture pressure. Minimum fixture pressure plus 0.434 into H plus H is what, guys? H is the topmost floor. H is the topmost floor. Height of the topmost fixture. H is the
স্যার
height of topmost. fixture. Topmost fixture means not this one, by the way. That means that the topmost fixture of
Upfield
your
zone.
upfeed zone. The topmost fixture of your upfeed zone. That is age, and you will determine this. You will determine this. Okay, that's your objective here. That how far you can go with this 50 psi, and small f is the frictional loss and other losses. Okay, so that's why I have what I have written. That's what I have written where here.
Sir, where will we get the frictional loss?
Yeah, that's a good question, and we will see this. So this is the input P plus other gain. If you have a pump or any other things, we do not have a pump here, so this is zero. We have only 50 psi from the main. Small p plus 0.434 into h plus f plus other losses. Fine. Now, the question that you have asked, that how would you know that how much losses will be there, right? It's a good question. Now remember, loss is mainly due to the friction. Loss is due to mainly loss is mainly due to the friction. Friction for what? In the pipe. So it is associated, friction is associated to the length of the pipe. Higher is the length of the pipe, higher is the friction. But the question is, you do not know the height of the, or not call it high, let's call it length. You do not know the length of the pipe yet. You do not know the length of the pipe yet because you do not know h yet. H is related to H is related to the L,
L.
length of the pipe. Now, let's say this is your, we do not know still, this is your upfit zone, and this is the main. This is the main, by the way. For example, this is the main. So this is your upfit zone. So height elevation difference is actually, let's say this is H. Hmm. And you also have 10 feet, or let's say just call it X. So what is your L, guys? L is equals to H plus X. Now if you know X, let's say this is 10 feet, so L equals to H plus 10, right?
Sir, x is the horizontal distance.
X is the horizontal distance and H is the vertical distance. Clear?
Yes, sir.
L equals to H plus 10. So now, if I tell you that per unit length of the pipe, per unit length of the pipe, the loss of pressure is M. So M equals to uh, MPSI per feet. This is the loss, frictional loss. Let's call it frictional loss equals to MPSI per feet. So what is the total loss, guys? Frictional loss per feet. So what is the total loss, guys? Total loss equals to, this is for 1 feet. So how many feet you have? L, right? M into L. Am I right? Equals to
Yes,
M
sir.
into H plus 10. 10 is not a fixed number. I'm just giving it for a demonstration purpose. H plus 10. So total loss due to friction is M into H plus 10. So what did you get from here? 50, 0. P is 15.434 into H plus, uh, let's see what they have there. This is a frictional loss. Frictional loss is what, guys? Frictional loss is,
M
as
into
I
L.
told you, M into H plus 10. M into H plus 10. If you have other losses, you'll have to put it here. Loss due to bending, as I told you, there will be bends and others, so there will also be losses. So this is, if this is given, m, small m is given, then cannot you calculate h from here?
Yes, sir.
Cannot you calculate
Yes, sir.
h from here? Okay,
Yes,
fine. Now the thing is, here you still do not know this h and m is not given, by the way. In reality, m is not given. Why? Look at this. This figure tells you the pressure losses in water meter. Guys, you will have meters in your, uh, this is a building, for example. Takawasa provides meter here, right? Which can calculate how much water is flowing, how much volume of water is flowing, and according to that, they make the bill. You have to pay the bill accordingly, right? So there's a meter. And when the water passes to the meter, there is always loss. In your fluid mechanics, you know, like a venturimeter, there is always a loss, right? So that also has to be calculated from here. If you know the discharge flow and if you know the pipe size, then from here you can calculate the pressure loss. Did you see pressure loss? If you know the Q and if you know the size of the pipe, then you can calculate the pressure loss. Clear? Now
yes, sir.
another figure, look at this. This also gives you the pressure drop psi per 100 feet of pipe. Now, to calculate this loss, what do you need to have? You need to have the pipe flow rate. I mean the water flow rate of water, as well as you need to know the size of the pipe, as well as you need to know the size of the pipe. Now you can calculate the flow rate of water still, but you still did not determine the size of the pipe. Did you determine the size of the pipe?
No.
No, sir.
No. So you do not know the size of the pipe. That's why you cannot exactly tell that okay, this is my pressure drop. That means you cannot exactly tell the value of m, a small m. You do not know. So what do? You can assume a value for this. For example, we can assume okay, let's say this is 8 feet, 9 feet, 10 feet, 8 psi, 9 psi, or something like that. So here, uh, let's assume they're assuming a 5 psi drop in piping, 5 psi drop in piping from experience, and these plus 3.5 from the meter. Total is 8.5. That means your AF is m into h plus 10. You cannot determine a small m right now, so you are assuming that this is 5. In addition to that, other losses means what? For example, the loss in the meter, as I told you, they're assuming this is 3.5 approximately. So 5 plus 3.5, how much, guys?
8.5.
8.5. So this is 8.5. Together these two makes 8.5. Now you calculate the value of h, guys. Calculate the value of h. 50 equals to 15 plus 0.434 into h plus 8.5. Tell me the value. 50 equals to 15 plus 0.434 into h plus 8.5. Tell me the value of h, guys. Is
61.1.
61.1 feet, of course. So this is the height of the top fixture. That means from here, how much far you can go, how much height you can gain?
61 feet.
Approximately 60 feet. Now, if your floor to floor height is 10 feet, then how many floors you can cover, guys? 60
6
by
floors.
10. That means approximately 6 floors, including the ground floor, by the way. In North America, they don't consider ground as the floor. Okay, in that case, it will be fifth floor. But if you consider the ground as a floor, then it will be sixth floor. Clear? So
Yes,
that's
sir.
why you see here zone one. Your zone one is limited to up to this zone one. You cannot go beyond this with this main pressure. So this is your upfeed zone. Zone one. Zone one is upfeed zone. Upfeed zone. Clear?
Yes, sir.
So each equals to 61 feet.
Sir,
And from there, they get this. Yeah, go ahead.
so should we always assume the value of m into h plus x?
This assumption are you talking about?
Yes, sir.
Okay, I'll come to that point. So to end this upfit zoning, if the 10 floor to floor height is 10 feet and 6 stories are indicated for the height of the upfit zone, we must remember that 61 feet is from public main to top fixture. Therefore, a deep water main would limit us to 5 floors. That means sometimes your water, this meter is under the ground. So if this is already 10 feet below the ground, then you will lose 10 feet under the ground, it will be 50 feet. In that case, you will have 5 floor coverage. Let's say you have up to out of 25 floors here, we will be able to provide 5 floors as a feed zone. Is it clear for everyone?
Yes, sir.
Okay.
Yes, sir.
Now your question. Come back to your question. Here we have assumed the value that okay 5 from here, 3.5 here. Why? Because we do not know the size of the pipe. But as we move forward, you will see at a time we will be able to determine the size of the pipe. Okay, so once you know the size of the pipe, for example 5 inch or something like that, then we will go back to the figure here. We'll go back to the figure here, and then we will be able to calculate the estimate the pressure drop. Now compare this actual pressure drop with the pressure drop that you have made assumption here. If this is close, then no correction is needed. If this is not close, then you have to make correction and do it again. So this is a trial and error process. Did you get the answer of your question?
Yes, sir.
Okay. So now let's talk about the downfield zone. Okay. In case of upfield zone, always remember in this equation, upfield zone, this is the minimum fixture pressure, guys. This is the minimum fixture pressure, right?
Yes, sir.
Because why?
Yes, sir.
Because as you move upward, the pressure is decreased. As a result, the topmost floor will get the lowest pressure, and that's why your concern is whether you would be able to provide the minimum fixture pressure here. So that's why you have to provide minimum fixture pressure. Always remember, for upfeed zone, minimum fixture pressure here. Minimum. Now for downfeed zone, there is a difference. In case of downfeed zone, let's say this is your downfeed zone. You do not know the height still. You do not know the height. Now, as you move downward, the pressure increases or decreases. I
Increases.
I
Increase.
already elaborated this before. The pressure increases downward because your H increases, the pressure also increases. So, who will get the highest pressure? The bottom, the most bottom part of the zone, right? So highest
Yes,
pressure.
sir.
So minimum pressure is not a concern here. The concern is maximum pressure. So here your concern is the maximum pressure. That means you have to be aware that your pressure is not so high that it will break down the fixture. You have to make sure that the pressure is not that high that it breaks down the fixture. So in case of downfeed zone, limiting the downfeed zone, your concern is not the minimum one, your concern is the maximum one. Clear?
Yes, sir.
Now, same thing again, input equals to output. So we need to determine how far we can go H with this downfeed zoning system. This is downfeed zoning because the water is flowing downward. We are providing the water from the overhead water tank, right? So here. Now, what is the maximum fixture pressure? Yes. Maximum fixture pressure at any fixture is not to exceed 50 psi. That means if the pressure increases more than this, your fixture will be broken down, right?
Yes, sir.
Now,
Now,
how do you determine this? Easy. Down phase zone. For 1 feet, how much you gain? 0.434. No, you need to determine the height, right? So 0.434 psi, you go 1 feet. For 1 psi, you go 1 by 44 feet. For 50 psi, why? Maximum fixture pressure. You go how much? 50 divided by 0.434. Can you please tell me the value? Can you please tell me the value?
115.
115.
Approximately feet. You can determine this by another technique. As I told you that in case of downfield zone also, again here input equals to the out input equals to the output. So here what is your input? Your input is what? You're gaining energy from the overhead from the potential energy. So 0.434 into H is your input here. Higher is the H, higher is the input, higher is the pressure. So your input is 0.434. And output is what? Output is 50 plus frictional losses and others. Okay. So let's say frictional losses we don't consider. We'll consider it later. So from here, h equals to what? 50 divided by 0.434. And what is the value you said? Approximately 115 feet. Now, let's say for frictional losses, you lose some. Let's say 20 feet, approximately 90 feet. That is the 15 feet. You lose 15 feet for frictional losses. So how much you have remaining, guys? 100 feet, right? 100 feet,
Yes,
right?
sir.
So for 100 feet, how many floors you can achieve? 10 floors approximately, right? Huh? 10 floors, right?
Yes, sir.
Okay, so 10 floor. And also remember that from here, the height of the water tank is what, guys? For our case, it was approximately 24 or 25 feet, right? The minimum height of the water tank, right? Hmm?
25.
25 or 20 or whatever. You can adjust it later. We are assuming. We are just assuming. So, uh, 20 minus other frictional losses. So, you can assume approximately 100 feet. From here, you got 115. 115. Then minus the 20 feet, if you look at the top overhead water tank, this is the 25th floor, maybe. So from here, this is 25 feet, 25 feet. So from here, this is approximately 10 feet, for example. So this is 15 feet, right? This is 15 feet. This is 25 feet. This is 15 feet. So 115 is from there to the lowest part of the downfield zone. So let's say if you deduct this 15, you will get 100 feet. This is 100. So 10 floor. 10 floors. So 25, let's say from 16th floor to 15th floor, right? Then it makes 20. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. How many floors? 10 floors. Clear?
Yes, sir.
Okay. So this is your another downfeed. So this is your first downfeed zone. Now what will you do for these floors? For 15th floor, 14th floor? Can you provide pressure? Can you supply water from this tank? No, because if you supply water from this tank, then the pressure will be exceeding the 50 psi, and it may break down your fixture. So what we can do is we will provide another tank. What is the minimum? 20 feet. So from 15, 20 feet height, we will provide another tank. And from this tank, we will supply water for this 15, 14, and so on. And this is our upfeed zone. This is our downfeed zone. This is also another downfeed zone because we are providing water from this another tank, overhead water tank. So this is another downfeed zone. This is 10 floors. So 10 floors. Here is 10 floors, and here is 5 floors. What is the size of the building? 25. So 10, 10, 5. 25 floors. Clear?
Yes, sir.
Okay. So that's the end of the lecture. If you don't have any question, I'll end the
স্যার
lecture. Yes, go ahead.
স্যার আমরা স্যার এই একদম টপে মানে রুফ থেকে যখন পানি সাপ্লাই দিলাম স্যার, যদি আমরা ফ্রিকশনাল কোনো ফোর্স ইউজ করি মানে পানিটার প্রেসার কমানোর জন্য, তাহলে কি স্যার হয় না যদি নতুন ট্যাঙ্ক না ইউজ করে?
From here.
জি স্যার, ফ্রম হেয়ার।
Okay. Uh, if you look at the formula of the frictional head loss, okay, like this, F equals to what? Frictional, I'm sorry, yes, head loss, HF, due to friction equals to F into L by D, V square by 2G, right? Right?
জি স্যার।
So you could use a smoother pipe which has low frictional coefficient, or you could increase the diameter which will reduce your loss. That's true that you can increase the diameter from here, okay, to reduce the loss. But you have to remember that you have to provide a certain pressure, velocity, right? These things to provide the minimum requirement of a fixture. So to answer to your question, yes, this is true. You can change the diameter a bit to reduce the frictional loss. Oh, you are trying to increase the frictional loss, right? You want
ইয়েস
to
স্যার,
increase. Okay.
ইনক্রিজ দ্য
So in
ফ্রিকশনাল
that case,
ফোর্স।
you can reduce the diameter to increase the frictional loss so that your your water pressure does not exceed the 50 psi. That's true, but there is a limit. I mean, how much you can reduce the pipe diameter? There is a limit. Okay. So if
ওকে
you,
স্যার।
to answer your question, yes, that's possible to some extent, to some extent, but may not be possible to apply always, because you cannot reduce the pipe diameter to an indefinite limit. I hope that answers your question, right?
ইয়েস স্যার।
Okay, then thank you very much. Have a good one and stay safe.